so if we take a look at this first problem, it's 5 parentheses x plus 3 equals 40. So before we can start solving, we have to simplify this left side here. The reason we know we have to do that is because we have parentheses. So before you can start subtracting, multiplying, dividing, you have to get rid of the parentheses by distributing. So when you distribute, you're going to multiply the 5 by the x and the 5 by the 3. So that will get you 5x plus 15 equals 40. Be careful that you are multiplying the 5 by both of the numbers. So this is 5x, and then 5 times 3 would be 15. And then they're connected by this, by the addition, because 5 times 3 is a positive 15. So once you do that, you have no more parentheses, and then so the next thing you want to look for is your like terms. So if you have 5x plus 15 equals 40, on the left side here, there's only one term with an x and one term without an x, which means they are not like terms. You cannot combine them. And on the right side, we only have one number, so obviously you can't combine that with anything on the right side. So that's our cue to start solving. So when you're solving for a variable, you want to isolate it. So something you can do to remind yourself that you're isolating it is that you can circle it. So if you circle it, you know you have to get rid of the 5 and the 15 because those are the numbers on the left side of the equation that are not x. So what we need to do first is subtract 15 from both sides. So we start with something farthest away from the x, and then we move to the things that are closer to the x. So when you do that, you're going to subtract 15 from both sides of the equation. When we say both sides, we mean both sides of the equal sign. Make sure when you're solving that you don't lose this equal sign. So the equal sign is still between the two numbers. What you're doing is you're just simplifying it by using the inverse. So you'll get 5x equals 25 because the 15's here will cancel out. And then 40 minus 15 is 25. So our last step here, if we have 5x equals 25, is we have to get rid of this 5. So to get rid of the 5, we want to use the inverse of multiplication, which is going to be division. So if we do 25 divided by 5, we get x is equal to 5. So if you notice that our first step we distributed, we were simplifying, and then after that we could start solving immediately. So if you take a look at number 2, again we want to kind of follow that same pattern. So you think to yourself first, do you have parentheses? So we don't have parentheses on the left side, and we don't have parentheses on the right side, which means we can immediately start solving. So when you start to solve, we also don't have any like terms. So now what's a little bit different about this problem is if you notice you have an x on the left side and an x on the right side. So when you see that, we want to try and get it down to its simplest form. So to do that, we have to get all of the variables on one side of the equal sign. It really doesn't matter if you move the 6x or the 5x. But a strategy that we talked about in class is to try and move the smaller number so that you have to work with less negatives at the end. So if you notice 5 is smaller than 6, so we're going to start by moving the 5x over. You can't just move it over by adding it, you have to use the inverse of what's there. So if it's a positive 5x, to move it to the other side, you need to subtract 5x from both sides. And you should subtract it from the like term. So you can't subtract 5x from negative 2 because negative 2 does not have an x behind it. So when we do 6x minus 5x, that's going to simplify to negative 2 plus 1x equals negative 4. I'm going to cross out the two 5x's here to remind ourselves that's why we subtracted 5x from both sides, to get rid of these 5x terms. So now if you take a look at what we have left, we have negative 2 plus 1x equals negative 4. So we do have two options. We can move this negative 4 over, but that's going to create an extra step for us because if we move the negative 4 over, we're going to be left with 0 on this side. So if we want to try and isolate x, again, I'll circle that x to remind ourselves we are trying to isolate it. So if we would like to isolate the x, we really need to get rid of this negative 2. And again, you can't just get rid of something, you have to move it to the other side. So we move it to the other side using the inverse of subtraction, which is addition. And when you do that, these x's cancel out. Those 2's cancel out. And then we're left with 1x equals negative 2. So our answer here is going to be x equals negative 2. If you notice in both of these problems, we're done when we just have an x on one side and a number on the other. In this case, we could also rewrite this last step as x equals negative 2, because if you remember, if you have a 1 as a coefficient, it's just like saying x, because 1 times anything is just itself. But again, you can't stop until you have just an x, an equal sign, and a number on the other side.